Okay, now in this section we'll see more in detail on how IPv6 IPv4 address looks and how it is classified, and more about that. So IPv4 address is actually a 128-bit address, 32-bit address. So IPv4 is a 32-bit address in binary, so which means either it can be 0 or 1. It will be either 0 or 1. So again, this 32 bits, you can see this is a complete 32-bit address. Okay, either it can be 0 or 1, and again this 32-bit address is divided into 4 portions. Now group of 8 bits, 1 2 3 4 5 6 7 8, group of 8 bits will be in one portion, and then group of 8 bits, 1 2 3 4 5 6 7 8, group of 8 bits, something like that. It may not be correct exact, but I'm just writing it here, group of 8 bits. Okay, so and each and every portion, so we call them as portions. So IPv4 address is divided into 4 portions, and each and every portion is separated by a dot. Okay, we can either call it as a portion or we can call it as octet. Okay, and then we have 4 portions, or we can say 4 octets. Okay, but the problem here is the IPv4 address, it is little bit in binary format, which will be very difficult for us to identify and to write down. So it's not an easy thing for us. So to simplify that, what we do is, for our easy understanding, this binary format is converted into a decimal format. So how to convert in decimal format? We write 2 power 0, 2 power 1, 2 power 2, 2 power 3, and then 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Okay, so it's nothing but you need to say 1, 1, 2, 4, 8, 16, 32, 64, and 128. And if I write this number here, this number, it's 0, 1, 0, 1, 0, 1, and 0, 1. So it's all 0, 1, 0, 1, 0, 1. So wherever there is 1, we need to add those values. So in my example, 0, 1 means, so here 0, 1, we have to add this 1, add 1. Wherever there is 1, add those power values. So if I add 64 plus 16 plus 4 plus 2, so 64 plus 16, it's going to be 80, 84, sorry, it's not 2, it has to be 1, 85. So you can see 85. So this is the equivalent decimal value of this. Similar way, in the same way, if you convert this binary number, it will be 5. If you convert the third portion, it will be 191. In the same way, if you convert the fourth portion, it will be 1. So for our convenience, we are going to convert the actual decimal format into, binary format into the equivalent decimal formats. Okay, so when we are assigning, when we are writing our IP address, we write only in decimal format. Okay, but in the backend, the computer understands only the binary language, and it's going to convert the equivalent decimal format, and it's going to identify the devices based on that. Okay, so that's how it works. So I got some more examples here. You can see in my slide, another slide, I got the same example. In case if you want to convert any number into equivalent binary format, like I got 192 here, so we can simply write it as 128, 64, 32, 16, 8421. So it's 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 6, 7. And if I want to add 192, then in that case it will be, you need to add 128 plus 64, it becomes 192. So whereas the remaining portions, you just simply write them in zeros. In the same way, if you want to write 168, so it will be 128 plus 32, 128 plus 32, because 128 plus 64 will be 192. It will be more than what I require. 128 plus 32, it will be 160, 160 plus 8, 168. And remaining all portions, we need to simply write them as zeros. In the same way, if you want to write the binary value of 10, let's take an example here. 10, so I can write as 8 plus 2, it is 10, and the remaining all the numbers as zeros. Now this is how we convert from binary to decimal and decimal to binary. So in the future classes, we'll be getting into some more advanced IP addressing classes called subnetting. So there you need to know these conversions, and this is something a little bit basic you need to understand before we get into some advanced addressing concepts. Okay, So next thing, let's see how to assign the IP address. Okay, so to assign the IP address, we need to go to My Network Places. Normally, how you can go to either My Network Places here from the control panel, or on the bottom of your taskbar you can find Network Options. You can go to My Network Places directly, and then you can go to the adapter settings, and you can right click on any interface card, properties, the LAN interface, whatever we are using, and then we need to go to TCP IP v4 or v6. So I'm using Windows 7 machine, so by default the new operating systems which was released from Microsoft or any networking device, they do support IPv6 options. So right now currently I'm going to use IP version 4 properties, and here I can assign the IP address. So there are two options here. So either I can use tell the IP address, where I can manually decide what IP address I want to give. Now this is what we call as manual IP address, or I can tell to the device to get the IP address automatically. There are two options. Now automatically is an option where probably in your company networks, in a big size network especially, if you have a lot of computers in the LAN, let's say I got some 100 plus devices connected in the LAN, so going to each and every device, assigning the IP address is not an easy job. So instead what we do is we connect some device called DHCP server. Probably it will be running some kind of server operating system, maybe a Microsoft or a Linux server operating systems, and we need to configure the DHCP server here. So DHCP configuration is something beyond the scope of your CCNA exams, but just to understand the concept of DHCP, now in this DHCP we are going to define the range of the IP addresses, like what is the starting IP, what is the ending IP, like that we are going to define the complete range of addresses, and then we'll ask our clients to get the IP address automatically. Okay, so whenever you power on your device here, so what it is going to do is it is going to go and contact the DHCP server, and the DHCP server will check the range of the IP addresses, and it's going to assign the IP address automatically to the device. So if you want the automatic allocation of the IP addresses, we must select this option, obtain the IP automatically. So there are multiple ways to do that. Mostly in our labs we'll be using manual IP addresses, because we don't have too many computers. We are not going to use any DHCP here, but just an option we need to know. So more on subnet mask, default gateway, this is something we'll see in our next topics. We will be covering more in detail on that as well. So these are the options. You can see the same thing, and if you want to check your IP address, in the command prompt also we can go and we can type a command called ipconfig command. Okay, ipconfig. It's going to provide you all the information like what is the IP address, what is the subnet mask, and other information as well. So default gateway is actually the address of the router. We'll see that when we come to the routing configurations, we will be configuring some default gateway and verifying that as well. So this is how we assign the IP addresses generally to the devices in our computers. Now the next thing we need to understand is the range of the IP addresses. The range of the IP addresses. Now the range is actually what is the starting IP and what is the ending IP. What is the maximum number we can allocate in the IP address, and what is the minimum number. So the minimum number will be 0 and the maximum number is 255. Now why minimum number is 0? Because as we discussed, we have an IP address in 4 portions, and each and every portion is separated by a dot. It looks something like this: 192.168.10.10, something like this. But now if you consider any one portion, in each portion you have 8 bits. So if I'm going to write these 8 bits in terms of binary, it's going to be either all zeros. So the minimum number I can write as all zeros, and the maximum number I can write as all ones. Okay, so if you convert this into decimal value, so either I can write 0 or I can write 255, which means 0 is the minimum number I can use for allocation of the addresses, and the maximum number I can use is 255. So this is the range of your IP address. So you will never see any address, any IP address beyond 255. So 255 is the last possible number which we can use in our IP version 4. Okay. So now this further range, whatever the range we have discussed, the range of the IP address starts from 0 to 255. Now this range is further classified into classes. Now we call them into 5 classes, and then and then it said that we any address coming within the range of 0 to 127, we call that address as A class, and any address range within 128 to 191 is referred as a B class address, and any range within 192 to 223 is referred as a C class address, and then class D and class E. So the first thing, whenever you see any IP address, you should be in a position to identify the class. Let's take an example to identify the class. I'm going to take one example here, 172.16.10.10. Now my question here is which this address belongs to which class. Now to identify you need to see the first portion. Okay, so see the first portion, and this first portion 172, don't see the second and third and fourth portions. So 172 comes in between the range of 128 to 191, so it's a B class address. So which means the range is classified only based on the first portion, not based on the remaining 3 portions. Remember that. Okay, so these remaining 3 portions, whatever we are using, it can be anything in between 0 to 255. But if the first portion here, whatever the first portion here, if it is in this range, it will be referred as A class. If it is within the range of the B class, whatever is given on the list, it will be identified as a B class, or it can be a C class, D class, or E class. There is a difference in each and every class. We'll be getting into that more in detail, but the first thing we need to identify the class. Okay, so similar way, if you want to take one more example, let me take one more example here by writing some address 195.10.10.10. Now this address belongs to which class? 185. It's coming in between 192 to 223, so it's a C class address. So similar way, some more examples if you want to take, we can take as 45.10.10.10. It's a A class address because 45 comes in the range of 0 to 127. Okay, so last example, 225.10.10.10. Now this address belongs to D class D, because it comes in the range of 224 to 239. So the major important thing, or the basic thing you need to understand, is the identification of the class. So for that you have to remember this range. So identifying this range is very important. Okay, so the next thing, once we do this, so now the next thing we need to understand is, okay, where we use which classes. So if you're using any LAN and the WAN kind of things, so in the LAN and the WAN, it can be your private network, public network, internet, wherever we go, we just use only ABC classes, which are generally used in our LAN and the WAN. Whereas the class D is reserved for multicasting, and the class E is reserved for research and development. So let's try to understand what is exactly multicasting first. Okay, so before we go ahead and try to understand the multicasting, we need to understand some different kinds of communications happens in your network. So we have 3 different kinds of communications which generally happens in an IP version 4, and those 3 kinds of communications are unicast, broadcast, and multicast. Now the unicast, broadcast, and multicast are actually 3 different kinds of communications which happens in your network. Like the first one, unicast, is a one-to-one communication. So let's take an example. I got a LAN. In that LAN, I got plenty of devices connected in the LAN, and in that LAN, maybe one device is sending information and the other device is responding to the information. So which means in this LAN, even though I got many devices, only 2 devices are communicating. You are just trying to send the information to a server request, and the server is replying to that particular request. Or maybe you're trying to send the information to the gateway or the router, and the router is replying back to your information. So where only 2 devices are participating in the communication process, we call this as a unicast kind of communication. Now you can also have a broadcast kind of communication where one device is trying to send information to all the remaining devices. So one device is sending to all the remaining devices, one to all. So one to all means one device is sending, whereas everyone will receive it. So we call this as broadcast. Now there are 2 kinds of ways switches will do broadcast. Probably that is something I'll be discussing more in detail when we get into switching topics. And also there is something called broadcast address also is there. We'll see that in our next sessions anyway, in the IP addressing topic only. So broadcasting is a kind of communication where one device is trying to send information to all the remaining devices. Okay, we call that as broadcast. And then there's one more kind of communication. We have something called multicast, one to a group, or one to many, or we can say one to a group, where only a set of devices are involved in the communication. Like take an example, if you just get back to some of the live conferencing or live TV or radio broadcasting kind of applications, or it can be distance learning, I'm using some video conferencing applications, or any training, we are doing some WebEx sessions. So that is also one kind of multicast application. Okay, so it can be anything, like these are all different kinds of multicast applications. You might be watching some live TV or live matches on the internet, or it can be some corporate broadcast messages. These are all the different examples of multicast traffic. Now to host or to generate or to identify this kind of traffics, we have a separate range of addresses, that is your class D, 224 to 239. So this is the class D address range, and this address range is going to identify the group of multicast addresses who want to receive. So it's more different, like it's more different when you compare with your unicast or broadcast here. Now the major difference is in case of multicast, not everyone will receive it. So only the users who are sending a request, only those particular users will receive it. Just like if you want to watch live TV or live matches, whatever you are watching, some videos online, when you click on the link, it's nothing but you're sending a request that I want to join to the group, and based on that you will get a reply. And probably at the same time there are some multiple users also send a request, only that particular users will get that multicast traffic. Or we can do some video conferencing or conferencing where only the set of users can join based on the request. Or if you use some Skype or any other applications, they use some multicast traffic in the backend to support, to enable, to identify this kind of traffics. So there is a separate class, reserved for that. We call that as a class D address. So the class D address is reserved for multicasting, to identify these specific multicast traffic. There is a class D address reserved. Whereas there is one more address called class E, which is also we don't use. So which means for a normal devices, for a PC, computer, or the LAN router, we cannot assign these class D addresses because it is reserved for hosting or identifying a multicast kind of traffic. Okay, and class E also reserved for research and development, so we cannot assign these addresses. So even if you try to assign, let's try it. So I'm going to my network connections, I'm going to my properties here, and then TCP/IP properties. If I go and try to assign an address which belongs to class D, let's say 224, it simply rejects. You can see it says you cannot use 224, is not a valid entry, please specify the any value in between 1 and 223. So even if I try to give any address 240 or whatever it is, it will not accept. It will only accept the addresses in between 1 to 223, which is our class ABC ranges. So any address belonging to class D or class E are not applicable to the normal devices. You cannot use them for any device in the network.